All right, welcome everyone. So today we're going to talk about how to solve basic quadratic functions, and the first method that we're going to talk about is what's called completing the square. Now before we get to that, we need to do a couple of things first, and then we'll talk about how to specifically complete the square, right? So the first thing that I want to talk about is that we have what's called the square root property, which says that if you have x squared equal to some number, then what we can do is take the square root of both sides, and then you get that x is plus or minus whatever the square root of that number is. So to see a couple of quick examples of that, we have in this first example, x squared is equal to 36. So if we square root both sides, we get that x is equal to, well, what's the square root of 36? It's 6. And then, of course, we get plus or minus 6. Right, so that's simple enough. In part B, we have x squared minus 25 is equal to 0. Now, this isn't quite in the form that we need. We need x squared is equal to a number. So here we would, of course, need to add 25 to both sides first. But then we have that x squared is equal to 25, and now we can square root both sides just like we did before. And then we get that x is plus or minus, in this case, we want 5. So x is equal to plus or minus 5 in this case. Now in part C, again, we don't have x squared is equal to a number. We would have to get this 3 over first. And now we have the x squared is equal to 24 once we subtract the 3. And then now, when we square root both sides, we get that x is equal to plus or minus whatever the square root of 24 is. And then since this is not a perfect square, we'll have to try and simplify this a little bit. So 24, so what's a perfect square that goes into 24? We could think of this as 4 times 6. So then we could simplify square root of 4 as 2. And square root of 6, we can't take that any further. So combining these two things, we could say that our x is plus or minus 2 square root of 6. All right, so hopefully that's simple enough. We'll do one more where now we have a complex scenario, because now when we move the 11 over, in this problem, we get that x squared is equal to negative 11. Now, of course, we know that no real number satisfies this, but once we take our square root, you can see the previous video on the intro to complex numbers. We'll talk about this. We now get that x is equal to plus or minus square root of negative 11. But for square root of negative 11, we can think of that as an I times square root 11. So now combining these two pieces of info, we can say that x is plus or minus square root of 11 times I, or I times square root of 11, whichever way you prefer. Okay, so that's sort of the property that we're going to use in just a second here when we actually talk about completing the square. But in our case, it's going to look something that's more like this. Now, this doesn't quite look like what we have before because we don't have x, or it's just some variable equal to some number, but we're going to use the same idea. So this a minus 5 is just some number. And you might be tempted to FOIL this out and bring everything over to the other side. And while that's certainly fine, that's not what the emphasis of completing the square will look like. So now if we use sort of the same strategy, and we square root both sides, well then the left side will become just a minus 5, right? If I square root this and square root this, then we get a minus 5 is equal to plus or minus whatever the square root of 32 is. And of course, 32, we could write as 16 and 2. So that's a 4 square root of 2. So far we have that a minus 5 is equal to plus or minus 4 square root of 2. Now we can add the 5 to both sides, and we get that a is equal to 5. Now 5 is not plus or minus. We strictly added that to the right side. So this will be 5, but then we have plus or minus 4 square root of 2. And just to be clear here, when we say plus or minus something, we mean that we get two answers. We mean that one answer is 5 plus 4 times square root of 2, whatever number that comes out to be, and a is equal to 5 minus 4 square root of 2. So this is just sort of a quick way to write these two answers. Both of those will satisfy the original equation. Okay, and we'll do one more example of this, and then we'll talk about how we can use what's called completing the square. So in this one, we'll get another complex, because once we subtract 27 from both sides, we now have t plus 4 squared is equal to negative 27. So when we square root both sides, on the left side, again, the square root and the square cancel each other, and we're left with t plus 4. And then on the right side, we have plus or minus square root of negative 27. Now for 27, or negative 27, we can take an I out, of course. And 27 we can write as square root of 9 times square root of 3. So negative square root of negative 27 will all come out to be a 3 square root of 3 times I. So putting that over here, we have that t plus 4 is equal to plus or minus 3 square root of 3i. And last but not least, we would want to subtract 4. And we get that t is equal to negative 4 plus or minus 3 square root of 3 times I. And again, don't forget that this really means that you have two answers. We have negative 4 plus 3 square root of 3 times I, and also negative 4 minus 3 square root of 3 times I. So this is all well and good. And now we're going to use this in what's called completing the square. Now, in general, if you want to solve something that looks like ax squared plus bx plus c is equal to 0, generally what you would want to do is factor. But we, of course, have seen that not every equation that's in this form can be factored. So we want a way that if it can't be factored, what's another way that we could solve this, right? And that first way that we're going to talk about is what's called completing the square. So the first thing that you would want to do is you want it to specifically be this form. And one thing that you need to pay close attention to is that the coefficient of x squared here is 1. So the first thing you need to do is to make sure, and you can multiply or divide everything in your equation by some number, which would result in your x squared having a coefficient of 1. So if that's not already done, that's the first thing that you want to do. Then the next thing that you would want to do is you want to rewrite the equation with the constant on one side and then the x terms on the other side, right? So that's what this step 2 is saying. Put the constant on one side and then your x squared and your x term on the other side. Now this third step is the part that nobody likes, but we'll do a couple of examples and hopefully it's not too bad. So the key here is that you need to take 1/2 of what the x term coefficient is, or in other words, this is usually like your b term. So what you need to do is you need to take b over 2, because you want to take 1/2 of that, and then you're going to square it, and you're going to add that to both sides of the equation. And what that's going to allow you to do is that your terms with your x squared and your x will now be able to be factored as a perfect square. And that's what this fourth step is. You're now going to factor that. And then for the rest of the problem, we're just going to do what we've just spent the last couple minutes practicing. You're going to take the square root of both sides and solve for the variable. All right, so let's do an example. So the first example that we're going to do is one that you would normally do by factoring. So this is something you would normally solve with factoring. And you could do this fairly easily because you need two numbers that multiply to 8 and that add to 9. So of course you could use 8 and 1 there, and that would imply that x is equal to -8 and to -1. So when we do this with completing the square, that shouldn't change that that's what our answer should be. So let's just go ahead and we'll do it, and we'll make sure that that is indeed what we get. So let me just rewrite this down here. So we have x squared plus 9x plus 8 equals 0. Now here, notice that step 1 is already done, because your coefficient of your x squared is 1. Coefficient of x squared is 1. So we don't need to do anything there. Now step 2 is we want to write this as x squared plus 9x, and we want to move that constant to the other side. We want to move the negative, or we want to subtract 8 from both sides, so that we get x squared plus 9x is equal to a -8. Okay, now here's the fun part. So step 3 is we want to take this b term, this 9, so we have that b is equal to 9, and we want to find what b over 2 squared is. Well, b over 2 would be 9 over 2, and if we square that, in the top we're going to get an 81, and the bottom we're going to get a 4. So that's what we want to add to both sides. So now we're going to take our original equation, which is x squared plus 9x equals -8, and I want to add 81 over 4 to both sides. So of course we have a little bit of work to do since we have some fractions, but that's not an issue, right? So on the right side, we could think of -8 as -8 over 1. And I would need to multiply top and bottom by 4 to get a common denominator. So I have -32 plus 81 over 4. And that will come out to be, what is that, a -49 over 4, I believe? I believe so, right? So we get a -49 over 4. Oh, no, this should be positive, 49 over 4. Okay, so what do we have so far? Well, we have x squared plus 9x plus 81 over 4 is equal to 49 over 4. Now, the whole point of doing this is so that we could factor this. This is now a perfect square. We now can say that this is x plus, now what's the square root of your last term? It would be a 9 over 2. And we can write that as x plus 9 over 2 squared is equal to 49 over 4. All right, so this was our fourth step here. Okay, so let's come over here. We'll have a little bit more room. So we have x plus 9 over 2 squared equals 49 over 4. So now we're doing what we did before, and we want to square root both sides. So if we square root both sides, on the left side, we're just left with x plus 9 over 2. And on the right side, if we take the square root, we get a plus or minus. Square root of the top is 7, and the square root of the bottom is 2. So now once we solve, we get that x is equal to -9 over 2 plus or minus 7 over 2. So what does this come out to give us? Well, let's find out. So if we have x is -9 over 2 plus 7 over 2, that's -2 over 2, which is -1, which is, of course, one of our answers. So we should expect that. And what's the other one? Well, the other one is negative 9 over 2 minus 7 over 2, which is negative 16 over 2, which is the negative 8 that we also saw before. So now, of course, with this particular example, you would not do completing the square because you could do it in one line with factoring, right? So in this case, you would normally not do completing the square, but this is just to sort of motivate the strategy here. All right, let's look at another example. Now, in this one, I could move the x squared over so I can get a coefficient of 1, and we can add the 10 over. So now if we clear out what cancels, we're going to get on the right side, we have x squared minus 3x, and on the left side, we have 10. And again, if you were to just add x squared here, you'd get x squared minus 3x minus 10 is equal to 0, which would be another one that you could do with factoring. But again, we're just going to sort of do completing the square here just for demonstrational purposes. So again, we need b over 2 squared, which in this case would be a negative 3 over 2 squared, which would be a 9 over 4. So that's what we want to add to both sides. So I'm going to, let's put this on a little box here. I want to add 9 over 4 to both sides. So now on the left side, think of this as over 1 and then multiply top and bottom by 4. And we'll get 49 over 4 on that left side. And if I factor this, we can say that this is x. Since it's minus 3x in the middle, I'm going to need a minus. And then square root of 9 over 4 is a 3 over 2 squared. So of course, we'll square root both sides again. And we get plus or minus 7 over 2 on the left side, and an x minus 3 over 2 on this side. So then we can add 3 over 2. And we get that x is equal to 3 over 2 plus or minus 7 over 2. So of course we can take this further. One answer is x is equal to 3 over 2 plus 7 over 2, which is a 10 over 2, which is a 5. So that's one answer. And in the other one, we have x is equal to 3 over 2 minus 7 over 2, which is a negative 4 over 2, which is negative 2. So those are our two solutions for this particular equation. Okay, let's do one more, and then that will wrap up this video. Well, this should be equal to 0. That will wrap up this video on completing the square. Okay, now one thing that you would definitely want to do here is now that your coefficient of x squared is not 1, we can divide both sides by negative 4 in order to do that. So now the left side would be x squared minus 2x minus 8. Now 0 divided by anything is still 0, so that side won't change. Okay, so now let's move 8 over. And we get x squared minus 2x is equal to 8. So we now have it in the form that we want. And again, we want to find b over 2 squared. But my b is negative 2. So we have a negative 2 over 2 squared, which will be a negative 1 squared, which is 1. So this is what I want to add to both sides. So we'll add 1 here. And we'll add 1 here. So that we have x squared minus 2x plus 1 on the left side, and on the right side we have 9. So no fractions here, so that's kind of nice. So now we can write this as, again, we have a minus in the middle, so we want x minus square root of 1 is 1 squared is equal to 9. And now when we square root both sides, we get x minus 1 is equal to plus or minus 3. So then we can add 1 to both sides. We get that x is equal to 1 plus or minus 3, which of course will give us two answers. We get x is 1 plus 3, which is 4, and x is 1 minus 3, which is negative 2. All right, so those are a couple of examples on completing the square. I hope that you enjoyed the video, and I will see you next time.